Hello everyone, I am Chandanes, currently pursuing my MBA at Sri Venkateswara College of Engineering. Today I am here to represent a topic related to hypothesis testing two sample test from the subject Business Statistics submitted to Ajata Shatru sir, MBA department, subject code MBA 10. Now, getting into the topic Introduction to Hypothesis Testing. Define hypothesis testing, a systematic way to evaluate evidence and make decisions about population parameters. Null hypothesis HO, a statement of no effect or no difference. It's what we're trying to disprove. Alternative hypothesis H1 or HA, a statement that contradicts the null hypothesis. It's what we are trying to support. Significance level, the probability of rejecting the null hypothesis when it is actually true. Type 1 error. Common values 0.05, 0.01, and 0.10. P value, the probability of obtaining results as extreme as or more extreme than the observed results. As types of two sample tests, introduce two sample tests used to compare the means or proportions of two independent groups. T tests compare means of two groups when the population standard deviation is unknown. Examples: comparing test scores of two different teaching methods, comparing product performance. Z tests compare means of two groups when the population standard deviation is known or for large sample sizes. Example: comparing click through rates of two different marketing campaigns. Key square tests compare proportions or categorize data between two groups. Example: comparing the proportion of satisfied customers for two different service plans. Key differences: T tests are usually used with smaller sample sizes or unknown population variance, while Z tests are used with large sample sizes and known population variance, or when the sample size is large enough to assume the sample variance. Two sample independent t-test equal variances assumed. Scenario: comparing the means of two independent groups assuming their variances are equal. Assumptions: data is continuous, samples are randomly and independently selected, data is approximately normally distributed, the variances of two populations are equal. Check using Levenis test p is greater than 0.05 or F test. Formula: T is equals to x bar 1 minus x bar 2 divided by SP into square root of 1 divided by n1 plus 1 divided by n2. X bar 1 and x bar 2 sample means. SP is pooled standard deviation. N1 and n2 describes sample sizes. Degrees of freedom. Two sample independent t-test unequal variances assumed. Scenario: comparing means when the variances are not equal. Village t-test. When to use: if Leveni test or F test indicates unequal variances, P is lesser than or equal to 0.05. Formula: T is equals to x bar 1 minus x bar 2 divided by square root of S1 2 divided by n1 plus s2 2 divided by n2. X bar 1 and x bar 2 indicates sample means. S1 and s2 indicates sample standard deviation. N1 and n2 indicates sample sizes. Degree of freedom calculated using a more complex formula, which shatter weight equation to account for unequal variances. Example: compare the average test scores of students from two different schools where the variability in scores. Two sample z test. Scenario: comparing means when population standard deviation are known or for large sample sizes n greater than 30 for both groups. Assumption: data is continuous, samples are randomly and independently selected, data is approximately normally distributed, or large sample sizes allows use of central limit theorem. Population standard deviation are known Formula: z is equals to x bar 1 minus x bar 2 square root of deviation 1 2 divided by n1 plus deviation 2 2 divided by n2. X1 and x2 indicates sample means deviation 1, and deviation 2 population indicates standard deviation. N1 and n2 indicates sample sizes. Example: comparing the average salary of engineers in two different key square test for independence. Scenario: determining if there is a significant association between two categorizable variables. Data organized in a contingency table. Rows and columns represent the categories of the two variables. Hypothesis: H0, the two variables are independent, no association. H1, the two variables are dependent associated. Formula: x square is equals to sigma 0 minus e the whole square divided by e 0. O represents observed frequency. E indicates expected frequency calculated as row total, column total, and grand total. Degree of freedom: df. Common pitfalls and considerations: choosing the wrong test, understand the data type, continuous versus categorizable, independence of samples and assumptions of each test, ignoring assumptions, check for normality, equal variances, etc. Multiple comparisons, adjust the significance level, Bonforni correction if performing multiple tests on same data. Statistical significance versus practical significance. A statistical significance result may not be partially important. Consider the effect size. Sample size. Small sample sizes may lack power to detect real differences. Conclusion: two sample hypothesis tests are powerful tools for comparing groups. Understanding the different types of tests, their assumptions, and appropriate application is crucial for accurate conclusions. Always consider both statistical and practical significance when interpreting results. Use statistics